In rural areas in developing countries like the Philippines, houses are very diverse. They can look something like this one, or something like this, or a more natural version like this one. Regardless of how they look like, these houses are one of the most valued assets of households, but the problem is they're also one of the most disaster affected. And when we talk about disasters, most localities experience the impacts of not just one, but at least two hazards, emphasizing the need to address multi-hazard housing safety. The tricky part is that measures that improve the structure's performance with specific hazards may, in some cases, make the structure more vulnerable to other hazards. For example, building a lightweight dwelling might be good against earthquakes, but it can be very easily blown off by wind. The reverse is also true, that a heavy house can resist wind forces, but it can be vulnerable to ground shaking. Hence, construction trade-off decisions are considered in these scenarios to optimize structural safety. While humanitarian organizations strive to support communities after disasters, most communities, especially those in rural and far-flung areas, are forced to rebuild on their own with no or minimal external support using their own resources. This also means that they need to rely on their local knowledge of building a house, which is informally acquired within day-to-day experiences. Hi, I'm Arvin Hadlos and I'm a PhD candidate from the School of Civil Engineering at the University of Sydney. My research seeks to understand how self-rebuilding communities navigate the trade-offs in addressing multi-hazard housing safety. Out of this research inquiry, a construction optimization model or framework will be proposed for use in multi-hazard reconstruction contexts. For my research, I'm focusing on the case of Itbayat, Batanes, which is the northernmost municipality in the Philippines. The indigenous people in this area have for years built stone houses as a result of frequent typhoons, but these houses crumbled during an impactful series of earthquakes in 2019. To create an optimization model, I first surveyed the building stock in the community after the 2019 earthquakes to identify housing typologies that the households chose to build. I then evaluated the structural safety of these houses using fragility functions. Then, using interviews and focus group discussions, I elicited the factors that affected how households rebuild their dwellings. The next stage of my research is now the creation of the optimization model for multi-hazard housing safety using the data I previously gathered. I will be basing the optimization model on a concept in construction management called time, cost, quality trade-off analysis. However, the novelty of my research is challenging this triad to incorporate the complexity of the competing impacts of achieving multi-hazard resilience. I will also incorporate other factors which affect self-recovering communities in rebuilding their dwellings. For example, I have extracted from my interviews that regulatory barriers, like the stringent prohibition to cut trees, is affecting indigenous households to have access to hardwood, and this is affecting their capacity to build resilient dwellings. So, what are the contributions of my research? The creation of this optimization model is seen to provide a tool to aid more adaptive humanitarian programming. Humanitarian response has been critiqued for its blanket approach. With this model or framework, it will help humanitarian actors project how their intended interventions, be it material assistance or upscaling construction labor, can have impacts to achieving multi-hazard resilience. Second, the optimization model or framework can be used as a blueprint for government agencies to initiate multi-hazard risk reduction with policy insights on how local factors and contexts influence post-disaster rebuilding. Third, with the analysis of construction trade-offs, households will be guided with informed multi-hazard reconstruction decisions alongside the use of their local knowledge in rebuilding. My research also contributes to the Sustainable Development Goals. Under SDG 1, poverty reduction is linked to the promotion of assets among the poor and the most vulnerable, with the goal to reduce their exposure and vulnerabilities to hazards. Under SDG 11, sustainable cities and communities are envisioned to be achieved with the reduction of economic losses through a focus on protecting the poor and people in vulnerable situations caused by disasters. And lastly, under SDG 13, disaster resilience is promoted through the development of risk management strategies at all levels, similar to how my research focuses on the household level to improve the capacity of households to address multi-hazard resilience.